Next topic we are going to cover according to your syllabus, that is known as source transformation. Okay, what is basically a source transformation? That is conversion of one source to another source. Like if you know about it, we are having two source. One of the source is current source and another source is the voltage source. Okay, so we can easily convert the current source to the voltage source. Let's see how. If current source is connected in parallel with the resistance, then in that case, we'll be able to convert it into the voltage source. But there is must condition. What you need to remember, that with the current source, resistor must be connected in a parallel, but with the voltage source, resistor must be connected in series always. Okay? Like now suppose it's 10 ampere and 5 ohm. The resistor which is connected in parallel, same resistor would be connected in series 5 ohm. And in this case, V is equal to I into R. I means current, how much it is? That is 10 ampere. Resistance is how much? 5 ohm. So the voltage is how much? 50 volt. Okay. Now I'm converting back voltage source to the current source. Okay, now see, again voltage source is there, then that means resistor must be connected in series. I'm taking the same value, okay, 50 volt and 5 ohm. This is 50 volt and this is 5 ohm. And if we want to convert it into the current source, then see, if the current is moving in the upward direction, then we'll take the current source direction is like this on the upward side. The resistance which is connected in series, same resistance would be connected in parallel, if that is 5 ohm exactly. And now we need to get the value for I. I would be equal to V by R as according to Ohm's law. V is how much? 50 volt. Resistance is how much? 5 ohm. So I would be how much? That would be equal to 10 ampere. Okay, fine. Now see, this is the concept, but how in Manipal they'll give you the question. I'm drawing one question that already comes in your paper. Yeah, you can copy this. Now, first of all, you should know that how can we solve these kinds of question. You should know some of the rules. Like suppose if we'll have two current source are connected in parallel. Okay, and there is no element connected between over, above and down. That means their potential is same, right? So if two current source are at the same direction, then in that case the resultant current would add with each other. That would be 6 ampere. Now suppose if two current source are connected in opposite direction like this. Suppose this is 2 ampere and this is 4 ampere. Opposite direction means they will subtract with each other. 4 minus 2 is 2 only. So direction would be according to the current source which is having big value. So it is according to this. Okay? One another thing related to the voltage source, if two voltage source are connected in series, positive negative means they are connected in a series. So 2 volt plus 4 volt, you can finally write it down as 6 volt. But if two batteries are connected opposite is like this, ki positive negative positive, or maybe negative positive and positive negative. So both the signs are same, means the batteries are connected opposite. So in this case it is 2 volt 4 volt, 2 volt 4 volt. So the answer would be 4 minus 2 2. So what would be the sign according, जिसका sign बड़े वाले के according, तो इसका होगा negative positive 2 volt and इसका होगा positive negative 2 volt. ठीक है, understood? If two batteries are connected in series, add. If two batteries are connected opposite, then subtract. Now back to the question. As you can see that these two current source are there and no element is connected over here. That means they are connected in opposite. So we can simplify into a single current source. Correct? Hmm? 10 minus 5, it would be 5 ampere. Rest of the diagram is same. Now similarly, they ask you to calculate current in 10 ohm. So you don't touch 10 ohm. You need to simplify all the other stuff, but you can't touch 10 ohm. Understood? Because they ask you to calculate current in 10 ohm only. Now this one 5 ampere and 2 ohm, they are also connected in parallel. So you can simply solve it also. Further, if you solve it, 4 ohm and the resultant current source, they are also in parallel. So you can simplify it. Correct? Do it now. Okay, after solving this one and this one will got this value. Now you can see that 2 ohm, 4 ohm and 3 ohm, they all are connected in series, right? So if we'll combine it, it will be 9 ohm. Now we have to check for the battery. As you can see that this 10 volt and this 4 ohm, they are connected opposite, right? Negative is connected with a negative. So 10 minus 4 is how much? 6. Hmm? Now positive and positive, it is also connected opposite. So 25 minus 6 is how much? Hmm? Wait. Hmm. 25 minus 6 is 19. Wait. I didn't. Sorry. It's 10 minus 20, not 4. मैंने वो 4 resistance बोल दिया गलती से. 10 minus 20 is how much? 10, right? And 25 minus 10 is how much? 15. So we got the 15 volt. Correct? And rest of the diagram would remain same. It would be 6 volt and 3 ohm. And this one same. Now after this, what we can do? Tell me. Like we got this value 6 volt, 3 ohm, 9 volt and 15. Tell me what we can do it further. Yeah, whenever they'll say ki source transformation, then we have to use only source transformation. Okay, we can't use mesh analysis, we can't use nodal analysis. So now again we need to convert this voltage source into the current source. Correct? So it would be 9 ohm as I told you as it is, and that would be 15 by 9. 15 by 9 would be 5 by 3 ampere. Similarly, this 3 ohm will be as it is, and the current source would be V by R, that is 6 by 3, that would be 2 ampere. Correct? So if we'll solve it further, 5 by 3 and 2 ampere, they are at the same direction. Correct? And 9 ohm and 3 ohm, they are connected in opposite. Now tell me the final answer for this one. We'll get the final value for the current source and we'll get the final value for the resistance. Yeah. After solving this current source into a single source resistance, we'll get this value, and then we'll convert finally current source into the voltage source. Okay, as I told you, in whichever branch we need to calculate current, we can't touch that branch, right? So it would be 8.25 volt and the resistance would be 2.25 ohm. Then by using in the last, we can use Ohm's law. I is equal to V by R. V is 8.25, R is 2.25 plus 10. Then we'll get the final value for the current. This is how we can solve it through the source transformation. See, how can we do this question, as you need to calculate current across 8 ohm. So we can't touch 8 ohm, right? So always start from this side. If we'll do source transformation voltage to currents, we can convert this source, voltage source to current source, right? Now as you can see, these two current source are in opposite direction, correct? So resolve it, then the current source will be in single direction like this, and then after that convert it into the voltage source. Okay, after converting into to the voltage source, then you can connect it with the 3 volt, and downside you can connect it with the 2 ohm, right? So I simply solve this part up to here. I'm just giving you a hint. Then you can see that these two battery are connected in series. We can solve it, then again convert it into current source, and like so on. Do it up to here first. So these are the values: 3 ampere, 2 ohm. Then you will convert it, you will get 6 volt and 2 ohm. Okay. Now huh? Now after this, just cross check the values. 6 volt and 3 volt, they are connected in series, right? So ultimately it will become 9 volt, right? And 2 ohm and 2 ohm, they are also connected in series, so it will become 4, correct? So 9 volt and 4 ohm, I'm rubbing this. So this complete diagram will be replaced by a single voltage source, that is of 9 volt and 4 ohm, right? And after this we'll have 1 ampere and 4 ohm and so on, correct? Now again, as you can see that this voltage source of 9 volt and 4 ohm can be converted into current source. So if I'll convert it into the current source, it would be how much? 9 by 4 ampere and this 4 ohm, है ना? Then again 1 ampere, जो ये था 1 ampere, and the resistance is 4 ohm. So now you can see that 4 ohm and 4 ohm are connected in parallel, right? And 9 by 4 and 1 ampere, they are connected in series because they are in same direction, so that will add with each other. So 9 by 4 plus 1 will become a single current source. I don't know the value exact, but 2 resistance 4 and 4 ohm, it will resolve it into 2 ohm, right? So basically we have solved it up to here. Again we can convert it into the voltage source, right? If we'll convert it into the voltage source, then we'll get the value as 13 by 2 and 2 ohm, and with a battery of 5 volt, 5 volt and 8 ohm. So now you can do finally, like final result would be 13 by 2 volt, and the resistance is 3 ohm, and the battery is 5 volt, and the last resistance is 8 ohm. Now you can see that these batteries are connected opposite, right? Positive is connected with positive, so it would be 1.5 volt. Resistance would be, sorry, it's not 3, it's 2 only. Here we got the 2 ohm na, it's 2 ohm only. 2 ohm and 8 ohm. Now we can apply finally the Ohm's law, V by R. 1.5 divided by 2 plus 8, that would be 0.15 ampere. That is your final answer. Now after this we'll have the next topic, and that topic is star delta transformation. As I told you earlier, from these lecture 2, 3, 4, they'll, according to the end term I'm telling you, they'll cover only single question, one question. Okay, so now we'll study about the star delta transformation. Now see what is star delta transformation. For that we have to study the basic concept. Like suppose we'll have supply. That supply is divided into two parts. One is the single phase supply. Single phase supply means in which in a single wire we are getting the current. Another one is the three-phase supply. Three-phase supply means we are having three wire. One wire is of red color, another wire is of yellow color, another wire is of blue color. This is according to the Indian standard notation. And all these wires carrying different current. Okay, so three-phase supply we'll use in mainly hostels, hospitals, medicals, या जहाँ भी बड़ी बड़ी चीजें होती हैं वहां पे, because we need three wires to get supply. And single phase supply we are using at our home appliances. ठीक है, like in single phase supply remember we are using a socket like this. तो यहाँ पे कभी टेस्टर डाल के देखा हो तो will get a current in one single hole. देखा कभी? At the three phase supply, suppose I am giving you three wires. One is of red color, another is of yellow color, another is of blue color, and I am saying that you must need to connect these wires with each other. So one simple way you can connect red with the yellow with the blue, like you can tie at a one note. Okay, another way you can do it like this: red connected with the yellow and yellow can connect it back to the red, right? Now tell me, is there any another way of connecting these three wires? Tell me. Hmm? They must be interconnected with each other. No, now? So this looks like a star, that's why it is known as star connection. It looks like a delta, that's why it is known as delta connection. Opposite of star is also known as Y connection, that you are going to learn in detail in module 3 also. But now we are going to study about star delta transformation. That's why I told you in detail that what is exactly the star and delta. Okay? Now see, it looks like a delta. Like suppose this point is A, this point is B, and this point is C. And this is suppose R1, R2, R3. And this is star, right? This is RA, this is RB, this is RC, because this point is A, B, C. Note it down up to here. After that you can learn the formulas, like how can we convert delta to star. Okay, like for easy way I am merging this star and delta. Like suppose this is RA, this is RB, and this is RC. So if we want to convert from delta to star, now tell me which values we need: RA, RB, RC, or R1, R2, R3? If we want to convert delta to star, which values do we need in the answer? RA, RB, RC? No, we are converting from delta to star. So we need RA, RB, RC, or R1, R2, R3? RA, RB, RC. As you can see that RA is connected between R1 and R2, correct? So its formula would be R1 into R2 divided by R1 plus R2 plus R3. ठीक है, don't rely on handbook formula because that is completely different. I'm telling you the way of remembering also, correct? Now see, RB is connected between R2 and R3, so its formula would be R2 into R3 divided by R1 plus R2 plus R3. Now you tell me the formula for the RC. Next one is star to delta. Star to delta means we need the values for R1, R2 and R3, correct? Now as you can see, R1 is connected between RA and RC, so its formula would be RA plus RC plus RA into RC divided by the rest of the term RB. R2 is connected between RA and RB, so it would be RA plus RB plus RA into RB divided by RC. Correct? Now next numerical based on this. See, it's a simple numerical. It already comes in Manipal paper. Okay. In this, they said you need to calculate resistance across A and B. This is 30, 30, 30, 30. All the values are same. Okay? Whenever you will not be able to solve through series and parallel, then in that case you need to apply star and delta. If you'll be able to solve it through series parallel, then do it by that way only. Okay? Now if you are need to calculate RAB, then you will need to start it with the opposite of A and B, that is this one. Now as you can see that this 30 ohm and this 30 ohm, they are connected in series or in parallel? Tell me. They are at the same path, so that means they are connected in series. So 30 plus 630, oh, 30 plus 30 is how much? 60 only. So now you can see it's a 60. Okay, I'm drawing this again. ये था, ये था. Okay. Now again you can see that this 30 and this 60, they are connected in parallel, right? These are connected in parallel, so we can simply solve it and convert it into single resistance. 30 parallel 60 would be equal to 20. Okay? Now up to here we can do it by series and parallel. After that 20, 30, 30, 30, like these are not even connected with series and not even connected with parallel. Correct? Now tell me how we can proceed further. This is delta. Can we convert it into star? Similarly, this is also delta. Can we convert it into star? Tell me. And after converting from delta to star, we'll get the diagram like this. Like this is delta. We'll need to convert it into star, and the values for this one according to the formula, that would be 30 into 30 divided by 30 plus 30 plus 30. Correct? All three values are same because values same as sorry. 20 ohm we didn't touch. Correct? Again this is delta and we can convert it into star. So it would be this point. Let us consider this point C. C is connected with the 20 ohm. So I'm connecting C with the 20 ohm. This point consider as a D. D is connected with the 20 ohm. Right? So this is A and this is B. Okay? If I'll solve it, then it would be 10 ohm now. So it is 10, 10, 10, 10, 10, 10. Correct? Now further you can see that this 10 are in series, right? There is no other way connecting this 10 and this 20 again in series. Correct? Then we can simply redraw again 10, 20, 30, right? And 10, 20, then 10, and this one is also in series 10, 20, 10. So इसको भी combine कर दो, that will become 40. Right? ये देखो ये बनेगा. बन रहा है तुम्हारा? again it is becoming delta. This 10, 20 and 10 will become 40 and above ये वाला point और ये वाले point से connect हो गया, ठीक है. Now you can see this 20 and 40 are in parallel. इसको solve करके single resistance बन जाएगा. Then 10 बीच में जो resistance आएगा वो वाला and this 10 will become a resistance single in series. So the final answer, मैं तुम्हें final answer बता देती हूँ कि इसको solve करके क्या आएगा. That would be your 33.33 ohm. इसको solve करके you can cross check it.